Perfect. All right, thank you all for joining us this afternoon. As Susan mentioned, my name's Matt. I'm with the Fish and Wildlife Service, and I'm here to talk about the Great Lakes Mass Marking Program. Brief outline of what I'm going to talk about today. I'm going to go through a quick overview of our 2023 tagging and field recovery effort, and then provide brief updates on Chinook salmon, lake trout, and steelhead. So getting right into it here, in 2023, we marked or tagged a total of 10 million fish. That includes about 3 million lake trout, 3.5 million Chinook salmon, and 3 million steelhead, with a handful of brook trout at the tail end there. This figure you're looking at here shows the number of fish marked in millions on the y-axis, with the year on the x-axis, and you can see the three main species that have been addressed by our program are lake trout in green, Chinook salmon in blue, and steelhead in pink. In terms of our tag and data field operations this past summer, we collected just shy of 13,400 fish in our Fish and Wildlife Biotech Survey of the sport fishery. That covers Lakes Michigan and Huron. We are planning to receive data from the states from their creel programs and WEIR surveys as well soon to add to that total. We partnered with the Student Conservation Association to staff many of our biotechnician positions. This provided experiential opportunities for 7 interns, and it was a win-win for both our agency and the SCA program. And in addition to our core data collection, we did collect specimens for diet and stable isotope studies, a study to look at whether epi-DNA can be used to age steelhead, and a spring spawning lake trout study. In terms of our actual number of fish caught, you can see this table here providing the jurisdiction by columns, and each row is a different species. And you can see a healthy number of observations here for the 4 main species we observe, which are Chinook salmon, lake trout, steelhead, and coho salmon. We also see brown trout in Lake Michigan, Atlantic salmon primarily in Lake Huron, and pink salmon as well, again primarily in Lake Huron in 2023. In terms of some future plans for the program, we anticipate similar production and outputs next year as in this past year. This current year, 2024, is going to be the final year of steelhead tagging. We are having a study for coho salmon that is, the planting stages are underway. We anticipate starting tagging and marking coho salmon in 2025. Moving on to what we learned about Chinook salmon with the latest year's worth of data. I'm going to provide our annual update here of wild recruitment of Chinook salmon. This is an analysis based on looking at the fin clips, with hatchery fish not having a clip and wild fish having that intact adipose fin. We do estimate wild production from age 2 fish. We've learned and we presented at past meetings that age 1 fish, because they are smaller and because we see a smaller length at age at wild fish compared to hatchery fish, we do see some bias against wild fish at age 1. So we do still look at age 1 returns to kind of provide an early indication, but our final estimate comes from age 2 returns. Of course, one thing that I think this might be the final year we have to deal with in terms of Chinook salmon is that the 2020 year class was not marked at all due to COVID-19. So those fish in 2023 would be age 3. And so for this process, we looked at age 1 and 2 fish that had that adipose fin, and assuming those to be wild. Age 3 fish, we could not make that distinction. And then to actually get at the estimated number of smolts, we look at the percentage of wild fish in our observations in each of the management units. And then we use that with a ratio with the known number of stocked fish to figure out how many wild smolts must have been out there to produce the observed ratio of wild to hatchery fish. And so this figure here shows the estimated number of smolts in millions on the y-axis, with the year class typically estimated at age 2 on the x-axis. And you can see here the stocked smolts are in orange, the wild smolts are in blue. I do want to highlight 2 of the bars here. You can see they're kind of faded colors. First, we have 2020. We didn't have a field season then, so this value is actually the average value from the 3 surrounding year classes. So just want to highlight that that is not measured from the field. That is kind of a fudge factor, which is, I think, the best we could reasonably hope to do, given that we didn't have data from that particular year class. And then this 2022 year class, that's estimated from age 1 fish that we caught last year. That value will be updated at next year's meeting. So looking at these 2 most recent year classes, for the 2021 year class, we had the highest amount of wild production we've seen since the 2012 year class at about 8.5 million wild fish to produce almost 12 million smolts entering the lake. 2022, we have about 6 million wild fish and about 8.5 million total. So one thing I kind of want to look at and just take a step back here is if we take these stocked smolts out of this figure and just look at the trends here in our estimates of wild production, there are some interesting periods that emerge here. We have this 6-year class, 7-year class period where we saw relatively stable wild recruitment between 6 and 8 million wild fish a year. And then we had the 2013 year class happen. This was the year where we had about half of the lake in drought conditions during the fall spawning runs that inhibited adult mature fish from reaching the spawning grounds in much of the lake. And that was followed by a really severe and prolonged winter that could have affected availability of prey when those fish were smolting out. So that resulted in a period here of year classes where we only saw 3 to 5 million wild fish produced. And one thing I noticed during Ben's presentation just a few minutes ago is if you look at these fish, 2022 through 2018, those are going to be in the lake from 2014 through 2021. And that roughly corresponds with that period of record high weighted H3 fish. And as you saw in Ben's talk, that's starting to trend downward, and we're seeing that correspond here with this increase in wild recruitment over the last 4-year classes, where we're back to between 6 and 8 million fish a year produced wild for these last 4-year classes. Before I move on to lake trout, one other thing I want to highlight with Chinook salmon is that we've been talking about Chinook salmon survival patterns for a while. We have a paper in prep led by our research intern this last year, Brooks Harp, the main figure of which you can see on the right here, that's summarizing these findings. And basically we found high relative survival from fish stocked in Wisconsin, which you can see by these kind of deep red areas here. Low survival in these yellowish areas in Green Bay and MM6 with moderate survival elsewhere. And we did notice a relative survival decline from the 2011 through 2016 year classes, which I focus here because those are the year classes we had complete tagging of Chinook. Those tags were moved over to steelhead starting in 2017. All right, moving right along here to our updates on lake trout. I want to talk a little bit about the trends we're seeing in relative abundance of wild lake trout. We estimated relative abundance as the number of fish observed per sampling day for our technicians there in the field. We examined 3 large regions, southern Lake Michigan, which you can see here in dark blue, northern Lake Michigan in light blue, and Lake Huron in orange. This catch per effort was computed for each management unit in the lake trout working group distinctions as well. So if anybody is interested in those unit-specific patterns, I can provide those upon request. Values from districts where at least 20 lake trout were observed were then averaged to provide the CPE trend for any particular region. We are moving away from reporting percent wild. It's a poor metric for looking at wild recruitment patterns just because of the changes in stocking, and so we're not sharing percentage values for lake trout today. So this pattern here, this figure shows the wild lake trout relative abundance on the y-axis by sampling year on the x-axis, and you can see increasing patterns for both Lake Huron and southern Lake Michigan in orange and the dark blue. In northern Lake Michigan, we had a bit of an increase for the 2021 and 22 field years. That number did come back down a little bit in 2023. Remains to be seen how that will trend in the future. I'm going to provide a little bit of information now on each particular one of these regions. And in the next 3 sets of figures, you're going to see a black line for total lake trout relative abundance, a gray line for wild lake trout, and an orange line for hatchery lake trout. I know this isn't the Huron session, but this is the only Huron slide I have in here. And I just want to note here that, starting in 2012, 2013, we saw kind of a decline in the hatchery lake trout catch, and then that's been pretty stable, at least in our sport fishery data, since 2013. And so the total lake trout catch patterns are really reflecting the increasing trend in wild lake trout here in Lake Huron. In southern Lake Michigan, we see kind of these opposing patterns in hatchery lake trout in orange, which has been declining since about 2014, and increasing pattern in wild lake trout since about 2012. And so, we're encouraged to see continued increases in the relative abundance of wild lake trout in our sport catch samples from southern Lake Michigan. But the total lake trout catch up until very recently has largely been driven by the hatchery lake trout pattern. You can see the last couple years we're starting to see more of a signal there in the total availability of lake trout in this area, driven by those wild fish. And then one thing I also want to point out, I know Laura in her talk mentioned the stocking decrease. So what I put together here This is a figure that shows the number of yearling equivalents stocked or migrated on the y-axis. What this value includes are lake trout that were directly stocked into non-southern refuge waters of southern Lake Michigan, and then I've added to that lake trout that were stocked on the southern refuge multiplied by the percentage of fish that move into nearshore waters based on a coded wire tag movement study. We exclude the Klondikes from that. Those Klondike lake trout, we really don't see them moving off refuge nearly as much as the leans. And so we do see this figure, in my view, represents the availability of hatchery lake trout in southern Lake Michigan. In the sport catch, the age at which we get the most amount of lake trout is at age 5. So if we look at our hatchery CPE patterns, subtract 5 years, and overlay that on this figure, it's not a perfect fit, but you can definitely see the decline in hatchery lake trout offset by 5 years is pretty closely aligned to the declining availability of stocked fish. With that kind of early phase there, maybe a little bit not lining up, but once you hit the 2014 hatchery and the 2008 year class, you're kind of seeing that those trends pretty strongly overlap. Lastly, I want to look here at our data from northern Lake Michigan. Our coverage here is a little more sporadic, and so you can kind of see the hatchery lake trout pattern kind of goes up and then goes down and then up and down again. So we don't really see a consistent signal there for hatchery lake trout. We do see with wild lake trout, even though we did have a lower value in 2023, that was still higher than every other value on that figure except for the last 2 years for wild lake trout in northern Lake Michigan. So, hopefully we see a little bounce back there next year. So just to kind of wrap up the lake trout section here, wild lake trout relative abundance continued to rise in southern Lake Michigan and in Lake Huron, but stalled in northern Lake Michigan. Some projects we have on the horizon are to compare the Klondike Humper life history with lean strains in Lake Michigan and across the lakes, and to update the lake trout movement matrix. Then I'm going to close with some preliminary updates from Steelhead. I'm going to call all of these preliminary in part because we are still planning to receive data on the year classes with tags up until and through 2028 and beyond. And some of this stuff we really want to get a few more year classes in before we make any conclusive statements. But regardless, we do have more data now than we did last year. And so first I want to look at our wild production estimates for steelhead. Some lessons we learned from Chinook is that, based on the bias for age 1 Chinook salmon, where we see at smaller length at age, reduced catch of wild versus hatchery Chinook at age 1, those fish were typically 16 to 22 inches for Chinook. And so for steelhead, we want to find ideally an age that is going to be at least 22 inches on average, and it turns out that's age 3 for steelhead. So we're going to try to target age 3 fish for estimating wild production. COVID threw a wrench in doing that for all year classes, but that's what we're going to try to do. And then one of the challenges for steelhead that is not true for Chinook salmon is we do have different strains that are stocked out there with different growth rates and spawning times. So we're going to have to try to take that into account once we have data from a few more years. We also don't know if this is going to affect the best age to use for wild production estimates. But if we look at this figure, we're seeing the average length in millimeters on the y-axis versus age in years on the x-axis for the different strains that are stocked in Lake Michigan. And that first red arrow here on the left is at age 2. We see a mean length of 18 to 23 inches. That is lengths that we are concerned there might be a greater throwback rate for wild fish, and that's why we're looking at using these age 3 fish where we saw a mean length of 24 to 28 inches regardless of strain for looking at wild production. So in terms of our percentage values, you can see some of these we had to do at age 2. For 2017, we didn't have data in 2020, so we look at age 2 fish there. And then for this recent year class in 2021, obviously those fish won't be age 3 until this coming summer. So these red values, especially this one here, is kind of a preliminary value. I think this one here probably shouldn't be red anymore. But you can see for the 2017 through 19 year classes, we saw about 40 to 50% of these steelhead being wild. That number was much lower at age 2 for 2021. I would expect that number is going to be bigger when we look at these fish at age 3. So, take that with a grain of salt. On the whole, we're seeing fairly consistent observations with an otolith microchemistry effort that estimated about 40% of observations as wild fish. That's in a paper in prep by Ben Breaker et al. And so it's good to see some consistency there. If we look at a similar figure as we have for Chinook, again, we have the estimated smolts in millions, blue for wild, orange for stocked. For these first 4 year classes, we see fairly stable estimates of wild production. Obviously, with this current first look estimate for 2021 year class, that's come down. But at this point, we did look at the estimates at age 2, 3, and 4 for I believe the 2019 year class, and we do see increasing pattern of percentages with each advanced age. So I do think that number is going to come up next year. How much? It's hard to say. Some other things we've learned about steelhead. The steelhead populations are mixed during the non-spawning season, like Chinook salmon. One example I have here, these are steelhead stocked in Indiana, and the circles are proportional in size to the catch per effort of Indiana stocked fish throughout the lake. You can see those fish stocked in Indiana are being caught lake-wide. We are in the process of developing a kind of simple pie charts for each management unit to show catch composition by origin. This is an example of steelhead landed in WM5. That's the unit out by Milwaukee. And you can see a healthy mix of fish stocked in Illinois, Indiana, Lake Huron, Michigan waters, and then in Wisconsin waters as well. So this is just to drive home that point that everybody's catching everybody else's steelhead. One of the main findings we've learned for relative survival is that there's about 3 times higher survival for yearlings than fall fingerlings. And so this is kind of driven home by this figure. These are 3 units where we have both yearlings and fall fingerlings stocked. You can see in each of these units, the yearlings in orange have a much higher survival rate than the fingerlings in blue. And kind of the take-home talking point on that is fingerlings have made up about 20 to 25% of the steelhead stocked in Lake Michigan, but have only comprised 4 to 7% of the sport harvest. So moving to look at survival patterns by stocking location, we've looked at yearlings only. At this point, I've done some statistics with alpha set to 0.1, in part because, again, we are expecting part of the challenge with the stats here is we don't have that many year classes. We consider our year classes to be replicates. Same with the fact that we need more years of data to really hang our hat on these stats. I've mentioned that before, but we do start to see some patterns emerge where we have specifically here WM1, that's southern Green Bay. Steelhead stock there really don't survive well. That's just like Chinook salmon. We do see fairly good survival of steelhead stocked in kind of southern Lake Michigan, Indiana, MM7, MM8, as well as the Wisconsin small tributaries and MM123. If you're a spatial learner like me, this map may make a lot more sense to you. Here we see those same patterns overlaid with high in blue, moderate in yellow, low in red, and then no yearlings stocked in Illinois, so that's why they get a different designation here. So you can kind of see how those survival patterns are unfolding, and just for reference, this is the steelhead stocked from these 2017 through 2022 year classes, output from the Great Lakes DataViz website. So some conclusions for steelhead. All the states are depending on one another's steelhead. Poor survival in Green Bay, similar to Chinook salmon, with good survival in Indiana, MM7, MM123, and Wisconsin small tribs. Jury is still out on the strain comparison. We've seen some potential differences, but they're small enough that I wouldn't want to say they're meaningful and then have those trends reverse in the future. Next steps here for steelhead, we are going to continue to get data on age 2 through 4 fish through 2028. Those are the ages at which we see the most recoveries of steelhead and where we do our survival analyses. So we can continue to see updates for this for at least the next couple of years. We do want to explore strain-specific staging patterns for spawning and examine seasonality and the catch rates in different units. So with that, I'll thank you all very much for your attention, and I think I might have a minute or two for questions. Yep, thank you.